question 2 is saying calculate the steady state current in the 2 ohms resistor. The internal resistance of the battery is negligible and the capacitor has a capacitance of 0.2 microfarads. All resistances are in ohms. All resistances are in ohms. Okay, so that is question 2. Another question which is also direct to the point. So they have specified to say this is in a steady state current in a 2 ohm resistor or 2 ohms resistor. So there are some things that we have to put under consideration when we are dealing with questions that are containing capacitors or DC circuits that are containing capacitors. So since they've specified to say this is in a steady state, that means the capacitor that we are dealing with is fully charged. And if a capacitor is fully charged, it acts as a break in the circuit. It inhibits the transfer of electrons, hence it is considered an open circuit. So from here, that means we are supposed to already take out this part of our diagram. Why? It's because there is no current that is flowing through that part of the circuit. That's how capacitors work in a direct current circuit. And since they specified to say it's in a steady state, that means our capacitor fully charged, hence acting as an open circuit. So it is going to inhibit current from flowing through the 4 ohms resistor. So which means in the 4 ohms resistor, we're going to have zero current. And they're asking us to calculate the current that is passing through the 2 ohms resistor. And you can already tell to say the 2 ohms resistor is in a parallel combination with the 3 ohms resistor. The combination of these two is in series with the 2.8 ohms resistor and the 6-volt battery. That is what we are having. So we can now proceed to solving the question. So the first things first, we are going to calculate the equivalent resistance. The equivalent resistance in this top branch there where we're having our parallel combination. So I'm going to say my R total or my R23 will be equal to 1/2 plus 1/3 the power minus 1 like that. That means R23 is equal to, let me just punch this in. This is giving me 1.2 ohms. The combined capacity or the combined resistance of the 2 and the 3 ohms resistors is 1.2 ohms. And we said this combination is in series with the 2.8 ohms resistor. So in order for us to find the R total, we're just going to basically say R total will be equal to, let me put the equal just on top. The R total will be equal to 1.2 ohms plus 2.8 ohms. And this is going to give us the total resistance within this circuit as 4.0 ohms, like that. So this is the equivalent resistance in this particular circuit, 4.0 ohms. So now that we've calculated the total resistance, we are now able to calculate the total current that is flowing through this circuit, this direct circuit. And we're going to say total current total will be equal to voltage, which is EMF, over resistance. So the voltage is 6 ohms over the resistance, which is 4.0. So that means our total current in this circuit is going to be equal to 1.5 amps. The total current in the circuit is going to be equal to 1.5 ohms or amps. So this current flows out of the battery and through this 2.8 ohms resistor. And from there, it splits between the 2 and the 3 ohms resistor, since these two guys are parallel to each other. So what are we going to do in order for us to calculate the current in the 2 ohms resistor? We are going to use the same rule that we applied in question 1, which is known as the current divider rule. Like this, where we'll say the current in the 2 ohms resistor will be equal to the total current that is passing through this system multiplied by R total, or R in the opposite resistor, not R total, R in the opposite resistor over R total. of which the R total that we're talking about is the combination of the two resistors that are parallel to each other. So we're going to say um, our current in the 2 ohms resistor will be equal to the total current that we've calculated, which is 1.5, multiplied by resistance of the opposite resistor. The opposite resistor is the 3 ohms resistor here. The opposite resistor is the 3 ohms resistor, so multiplied by 3 over the total resistance, which is the combination of the 2.0 ohms resistor and the 3 ohms resistor. So we're going to have our 2 plus 3 as our denominator, thereby having a 5 there. And this is going to give us current in the 2 ohms resistor as 1.5 multiplied by 3 over 5, and this is going to give me 0.9 amps. This is going to give me 0.9 amps. So that's that, ladies and gentlemen. We have our current in the 2 ohms resistor as 0.9 amps, and that is the end of question 2. Can move on to the next question. Move on to question 3. Just rub here. Okay, so if question 3 is saying for the circuit below, calculate the current from the battery, 1, the terminal potential difference, 2, and the terminal potential difference of the battery, 2, and the power dissipated by the 12 ohms resistor. The power dissipated by the 12 ohms resistor. Okay, so in order for us to calculate the current from the battery, the first thing we're supposed to do is to calculate the resistance, because we know to say current from the battery is equal to voltage over resistance, like this. So we're supposed to calculate the total resistance around the circuit, and we have the voltage, which is the 12 ohms voltage, and we should be able to get the current in this particular circuit. Okay, so what are we going to do? You can notice to say we have our 18 ohm resistor there and our 6 ohm resistor there that are in parallel each other. Then we also have this system here that is in parallel with each other. So we can start by dealing with the systems that are parallel to each other. And from there, we're going to notice to say we're only going to remain with resistors in series. We're going to have this combination in series to 3, in series to this combination, in series to the internal resistance of the battery, which is the 0.5 ohms, like that. So this is how we're going to do it. We'll first find the resistance between the two pairs of parallel systems. So I'll say my R here, R 18,6 will be equal to 1 over 18 plus 1 over 6 to the power minus 1. So this is going to give us our R 18,6 as equal to, let me just plug this into my calculator. Just plug this in and see what I'm getting. Okay, so on the 18.6, we're having resistance of 4.5 ohms, like this. Then from there, we can calculate the resistance in the 24,12 resistor. So we're going to have 1 over 24 plus 1 over 12, the power minus 1, like that. And we also get R 24,12 as equal to, let me just plug this in again. This is going to give me 8 amps. Okay, so this is going to give me 8 ohms, not 8 amps, sorry. This is 8 ohms, like that. So we're now having 4.5 ohms here, 8 ohms here, 3 ohms there, and the 0.5 ohms there. So what are we going to do? We're going to calculate the total resistance around the circuit, and the total resistance around the circuit is going to be equal to, I'll say my R total will be equal to, I'll start with the 4.5, which is on the far left, plus the 3 ohms that we have there, plus the 8, which is the combined of the two parallel resistors, plus the internal resistance of the battery, which is 0.5. 0.5 ohms, and this is going to give me R total, which is equal to 16.0 ohms. 16.0 ohms will be the total resistance in this particular circuit. Now that we've calculated the total resistance in this particular circuit, what are we supposed to, or what can we do next? We can now start answering the questions that have been asked in the provided statement. Can now start answering the questions that we've been asked to find or to solve in the provided statement. So for part 1, For part one, we're going to say current is equal to voltage over current total. This is question one. It will be equal to voltage, total voltage over total current, or total EMF over total resistance. So we're going to say this will be equal to the 12 EMF that we've been given over the total resistance, which is 16.0. That means the total current in the circuit will be equal to 12 over 16. This is giving me 0.75 amps. So the total current from the battery is 0.75 amps. Question two is saying we should find the terminal potential difference. The terminal potential difference. So how are we going to calculate the terminal potential difference, ladies and gentlemen? This is very simple. The battery is providing EMF of 12. But this battery is having internal resistance. You can tell from the diagram that we've been given, there is internal resistance because there is an internal resistor. And this internal resistor is having a, let me do this. Okay. The internal resistor is having resistance of 0.5 ohms, which means there is potential difference that is lost within the battery itself. There is potential difference that is lost within the battery itself. Let me just, okay, so we now go to part two of the question. Okay, so terminal potential difference, there is this resistor. So there is internal resistance in this particular battery. So in order for us to find the terminal resistance, what we're going to say? We're going to say terminal resistance or terminal potential difference. So I can just say terminal voltage. Okay, so we're going to say V terminal velocity or terminal voltage, sorry, will be equal to the total voltage that is supplied by the battery that they're showing, which is the 12 volts, minus the voltage that is going to be lost due to the internal resistor. And this voltage that is lost will be equal to what? It will be equal to the current multiplied by the magnitude of the resistor that is internal, which is the 0.5 ohms resistor. So we've calculated the total current already to say it's 0.75 amps, and we know the value of the internal resistor. So this is going to be equal to what? This is going to be equal to 12 minus 0.75 multiplied by 0.5. And we're going to have our terminal potential difference, which will be equal to 12 minus 0.75 multiplied by 0.5. This will be equal to 11.625. 11.625 watts. 11.625 watts is the terminal voltage or the terminal potential difference that this circuit is going to have.